Okay, so we are going to talk about the situation where we've got, again, permutations. So by now you should know what permutation is. And we're going to look at when objects are identical, meaning you cannot tell the difference between two objects. So far we've talked about stuff like different letters and numbers, like we did in the quiz. We've talked about different people or different cars. But we want to now look at what are the cases when I've now got some things that are identical. How does that affect what we've got? So here we've got the different permutations for 4 different letters. I've got A, B, E, and R. So if I look at all this, it's written out every single combination. So I've got all the A's first, I've got some A, B's, switching them all up. So the total number of permutations that I have, just add them all up. You'll get 6 times 4. This should be an F. That's probably why. So in total, 24. Right, not too bad. If I wanted to do this using the method I've shown before, I've got 4 options, and I want to choose all 4. So 4P4, that'll give me the total number. So that's pretty straightforward. That's what we've seen before. Now we want to try this where we're going to make some of the letters the same. So let's suppose that instead of an F, I'm now going to put that as an E. So you're going to go along, you're going to change every time you see an F. Now this is an E. So go along, change all the F's to E's. Yes, this is going to be a tad bit tedious. You're just putting 24 lines on your page. But if you look at this, do you see any duplicates? You should, hopefully. Yes. Right? Now I've got these two are the exact same. And the one right next to it. And the one underneath it. So essentially what I've got, if I wanted to split this all up, oops, not here. Notice in each one of these boxes, they're the same. Here I've got BE, oops, I forgot this one. BEEA, BEEA. These are the same. I cannot tell between those. So now how many permutations do I have? We're looking for unique answers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yeah. So I've just halved this. I only have half the number of permutations. So let's try this out. So here I've got half as many. Let's see if we can further expand on this. So now let's say I'm going to change the E's and F's now to B's. So this one's going to take a little bit longer to go through all this. Change this to B, B, go through all this. And see if you can see now, where are all my identical permutations? Do you notice a pattern somewhere? Are there some rows that are even or columns that are the same? Look at the first row. What are each of these ones? Row is horizontal. What are all the top rows? They're all the same. A and then 3 B's. So that whole first row is the same. How about the second? B, A, B, B. The entire second row is the same. The entire third row is the same. The entire fourth row is the same. So now that I've only got a single letter with 3 repeats, now I've only got 4. Exactly. So how does this compare to the one we just did? Well, now I've got a third. Third is many. So this is just a little exercise so you can actually visualize how this affects what's going on. But I'm going to show you how we can calculate this a whole lot easier. I'm never going to ask you to actually write out each of the different options. That's just going to take way too long. So there's a way you can do this. Is anyone still writing this out? Yeah? Okay, I'll wait a sec. So I'm going to move to the next page. If you want me to come back and fill it in later, I can show you. So before I get into this, I want to show you the generalization because it's going to be easier to do this. So if I've got n objects, so if I look at E here, I've got 1, 2, 3, 4, 5. So n is just what's the total number of objects? And if I've got A that are identical, B that are identical, C that are identical, so here I've got 3 A's are the same and 2 B's are the same. So that's what it means by the A, B, C. So essentially this is the equation that we're going to use. Yep. So exclamation marks we're going to use quite regularly in this unit. The 3 dots here just means this continues however many repeats you have. So A, exclamation point, B factorial, C factorial, D, E, and as many repeats as you have, you're going to put those exclamation points. So let's look at how we can use this to solve some questions. So if I look at A here, I've got 1, 2, 3, 4, 5 total. So I'll put 5 factorial on the top because I've got 5 total objects. How many repeats do I have? 2. I've got 2 D's. So therefore, underneath, I'm going to put 2 factorial. And I don't do anything about the singles. We just leave those. So this you can plug into your calculator. If you haven't seen your exclamation point on the calculator, it is there. It's above the x to the power of -1 on this calculator. So you'll want to try this out for yourself, but this gives you 60. So I can write this out 60 ways. Give this a try on your calculator and see if you can do it. Shift, and then that one. You've got a different calculator. Yep, so 5, then do the shift x to the power of -1. You should see the exclamation point. And then divide, and then 2, and then the exclamation point. You found it, Husni? Perfect. So you're going to use this quite a bit, so it's good for you to get familiar with this. So let's try B. You got 60? Perfect. B, again, we've got 5 items total. How many repeats do I have in this case? 3. So 5 factorial over 3 factorial. Again, you can plug that in. You should get 20. The next one, again, we've got 5 items. And how many repeats this time? 4. Good. So you're seeing what's happening with the denominator. Every time I've got a repeat, I'm going to put a number in the denominator here. We're going to try that in the next one. I'll show you what that one is. So this one's just going to give you 5. So again, here's our triplet. Here's our quadruplet. D is where we start getting interesting. Okay, so I got 5 factorial, the same number. How many repeats do I have here? I've got 2 B's and I've got 2 C's. So every time I have a repeat, so because I have two b's, I'm going to put 2 factorial. And because I've got 2 c's, I'm going to put another factorial. So anytime I have a repeat, I'm always going to put that number of repeats on the bottom. So I've got 2 b's, 2 factorial. 2 c's, 2 factorial. So plug that in. So what's that? That'll be 16 divided by 2. That should give you 30. Sound right? Yeah, good. You'll probably need to put a time symbol in between these. The calculator doesn't like when you just put it like that. You got 120. Did you put it in the fraction form on your calculator? Because it might have been that it times it instead of divided it. Yeah, so when you do it like this, it's going to divide by this, but then it'll put the 2 factorial on the top. So you'll want to either put divide by that and then divide by it again, or put it in brackets.
Oh, so like 5 divided by 2 normally, and then just brackets.
Yep. So then the next one, again, we've got 5 factorial over, I've got a triplet of a's, so 3 factorial. I've got a double of b's, so 2 factorial. And again, you'll probably have to put a times in there. So let's see, what does that give us? So we got 20 divided by 2, so that should give you 10. The fact that 5 factorial over 3 is 20. So that's this part, and then I'm dividing by 2 factorial, which is just 2, so 20 divided by 2 is 10. Yeah, I'll give you a sec to write it down. So this is how easy today's lesson is. It's just simply going to be doing something like this. Mm-hmm.
I don't understand if it's A, B, C, D, E.
Mm-hmm.
How come the options were the ones you gave us? There are no options. Because if you go up to the letter combinations,
Yeah.
you can go E, B, F, C, and then you can go E, B, D, C. You can keep going with this. You only gave us one option for E to start, and then one option for A to start.
On the previous page, I didn't. I had every single combination. You mean for this one? So here's my A starting. Here's B starting. Here's E starting, E starting. Here's F starting, F starting. Here? No. AB first, AB, then you switch the next two. Then you can have AE, where you have BF first, then FB. And then you have AF first, where you have BE, and then you switch those. It's 6 options per first letter. It does work. You can try it and put them all out, but it does work. So this is a very, the 2 examples I'm going to put here, these are the very common questions that you will see coming on the test. These are the main way that you see these written out, and when you do the practice problems, you'll see them too. So I want to know, what are the number of permutations for words? We're just doing the exact same as above. Nothing's changed. I'm just giving you words instead. So there's 12 letters here, is that what you're saying? Yeah. So I've got 12 letters total. So I'll put 12 factorial on the top. And let's find doubles. So what's a double that you can see? Or triples? S? Okay. So I've got 2 S's. So I'll put 2 factorial. I've got 2 A's. So let's put a 2 factorial. Notice I'm crossing things out as I go to help keep track. Yeah, so I'm not done yet. There's 1, 2, 3 T's, so I'll put a 3 factorial. I've got 1, 2, 3 I's. And then a single C line. It doesn't matter. Just like it doesn't matter what order you multiply, you can switch these around and that's fine. So that's how I normally do it, is I start crossing things out so that I can figure out what's going on. This one I cannot do in my head.
It's a very big number.
I believe it.
You know, where are the three?
The T's and the I's.
Yeah, 3 T's, 3 I's.
And what's the second T?
A's and S's. 3, 3, 2, 6, 4, 0, 0. So 3,326,400. Yeah.
In this one, which one, what, we just put like 2, 3, 3 in between the brackets, right?
So when you're doing this, do 12, and then the bottom part you can put in brackets and then put a times in between each of these. So that's probably how you're going to have to write it on the calculator, or use the where it actually puts it into the fraction form for you. Instead of using the dividing sign, use the fraction. So let's now try rewriting Canada. So I've got 6 letters total, so 6 factorial, divided by, do I have any repeats?
Yeah.
Yeah, what am I
3
repeating?
A's,
I've got 3 A's,
and that's it.
and that's it. So then this is all you need to calculate. 120, yeah, that sounds about right. 6 times 5, 30, 30 times 4, yep. So if you can do these ones, you are set. This is going to be essentially what's going to be on the quiz tomorrow, something that's just like this. The way that this now becomes tricky is when I start putting some restrictions on this. So if we look at example 2 here, we've got how many ways can the letters in Canada be arranged if I tell you that the first letter must be N and the last letter must be C. So this is if I have no restrictions. Now I'm going to place some restrictions. So if I look at what I'm trying to do with this, I'm going to have 6 spaces. 1, 2, 3, 4, 5, 6. You are told the first letter has to be N and the last letter has to be C. So how many options do I have for N? I've just got one N. And in Canada, we're doing Canada. So there's only one N. Sorry? Yeah, write them underneath, yeah. Well, let's take a look. How many options for C do I have? I've got 1. So those ones are the restrictions. The rest, there's no restrictions. So for these, 4 in the middle, I've got the option of A, and D. This looks very familiar from what we just did at the top of the page. So in order to calculate the number of options for this, I've got 4 total. And I've got how many repeats? 3. I've got 3 A's. So this is just going to be 4. Yeah, but this makes it easier. So if you wanted to do this without a calculation, you could. This is just a general method that you can use every time. So if I want to actually solve this, what I'm going to do is I'm going to take the number of options here times the number of options for these next spaces, which we already solved for is 4, times this last one. So it's just going to simply be 4. Now, I wrote this out explicitly, and I did this because sometimes maybe I would say, what's the number, or let's say I said the first letter has to be A. So if the first letter had to be an A, how would this change? So 1, 2, 3, 4, 5, 6. So if I said this has to be an A, this has to be a C. So just to try a little experiment here, how many options do I have for A?
3.
3. How many for C?
1.
Just 1. And then what am I left over with for this middle section?
N, A, A, D.
And D. So in this middle section, I've got 4 total. So 4 factorial over 2 factorial. So 4 times 3, this is going to be 12. Because 4 times 3 times 2 times 1, so 4 times 3 is 12, times 2 is 24. 24 divided by 2 is 12.
What math did you just
This. Factorial means that number times every number less than it until it reaches 1. So 4 factorial is 4 times 3 times 2 times 1. 2 factorial is 2 times 1. So that one's not too bad to do in your head. So then if I want the total here, 3 times
36.
12 times 1. So in this case, 36.
Where did it come from?
Unless there is the number in the beginning, where the letter. If the same as something in the middle, that the count is a different, like a different one. You know what I mean? So if it's A and there's an A, does it count if I change the A from the left to the A?
From the first one?
Yeah, does it count the extra one?
Because in this case, yes, it would be because we're talking about it outside. If we're talking about it here in the inside, like we did here, it would just be this. Any other questions with this? Okay, so that's today's set of notes, right? I don't have anything more than that. Or is there one more page? Oh, yeah. Yeah, I can do this one pretty quickly. This one's going to be basically the same. So this is a special case where you have a starting place, you have a finish place, you want to travel there, and you can only travel south or east. So essentially what we're going to do is we're going to turn this question into a question that we just saw. So if I wanted to go from the house to the school, there's a whole bunch of different paths, but I could either go, something like this, and then like this. I could go like this, or like this. I could take some complicated route down in the middle like this. But the essence of what I'm trying to do is I need to move 3 squares south, and I need to move 5 squares east. Yeah. So it doesn't matter what order I put these, or it doesn't matter the order. But notice I'm always going to have 3 souths, 5 easts. So this path, if I were to do this, I would go south, 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 east, 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 and 5 easts. If I were to travel this path, I would just order it as first east, then another east, then another east, 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 then 3 souths. Yeah, just give me a sec. So in this one, I would first go south, then I would do 2 easts, then 2 souths, and then 3 easts. So I've essentially just taken my path and made it into permutations of 3 s's and 5 easts. So I just need, what's the permutation when I've got 3 s's and 5 easts? Yeah, you had a question? Yeah. So the house is 3 blocks north and west, but she's going from home to school, not from school to home. Yeah, so from school, it's 3 blocks north and 5 blocks west, but I want to go the other direction. So it's just the reverse. So if I wanted to get the total number of combinations with this, or permutations, I've got 1, 2, 3, 4, 5, 6, 7, 8 total letters. And I've got 5 easts, and I've got 3 souths. This one I also cannot do in my head. Should give you 56. So just to be clear about this, you've got 3 S's, you've got 5 E's, and we're trying to figure out what's the permutation on that. Any questions with this? Okay. The other method with doing the diagram is a little bit more complicated concept-wise. I'll show you it, and then we'll see if you like it or not. Some people like this one more. I like this one more than the other one, but most people prefer the top one. Okay, so what we're going to need to do for this is we're going to actually trace out the path with this. So if I want to reach this dot, if I can only go this way or this way in the whole thing, how many ways can I reach this dot from the home? Just one. I go down this way. There's one way I can reach this dot. How about this dot? Yeah. There's one way I can get there. If I wanted to reach this dot, there's 2 ways. I can either travel from here, which there's one way to get this way, or I can travel from here. So there's 2 ways I could get there. What if I wanted to reach this dot? Just one. I can't go backwards this way. I can't go upwards this way. I can only go down. So there's one. How about this dot? I can come from this way. There's one from here. Or I could come from this way, and there's 2 ways I could get here. So this one's actually 3. There's one way coming from this direction. There's 2 ways coming from this. And you just go through it and do all the dots. So here, there's only one way you can travel. So this is a 1. If I'm doing here, I could either come from this direction, there's 1 path. Come from this direction, there's 3 paths. And there's a 4. See? If you get it, this way is easier. If you don't, stick with the other one. But the pattern continues on like this. So all you're going to do is you're going to go dot by dot and figure out how many ways can you get there. So to get to this dot, there's only 1 path because there's 1 here. If you want to do this one, 2 coming from this way, 1 coming from this way. That's a 3. To get to this dot, 3 from this direction plus 3 from this direction. This is a 6. To get here? So to get to here, I can come from this way or this way, correct? And to get here, there's 3 ways. Yeah, so you're just basically following this pattern. So all you're doing is you're adding up the 2 branches coming into this. So this one's 10. Over here, there's just 1 branch coming in. This one, there's 4 because I add these 2. This one, there's 10 because I add these 2. This one, there's 20 because I add these 2. If this is not making sense, just ignore the next 2 minutes. Add these, you get 5. Add these, you get 15. 35. This one's just 1. Add these, you get 6. Add these, you get 21. 35 plus 21. the exact same thing. So if this method doesn't make sense, don't worry about it. Okay, you can always use the above method. This one's a nice one. If you have the path already laid out, it's pretty easy to follow it along. But if you don't like it, don't do it. That's the notes. You don't have the numbers written on the page there, so let me